All right, let's dive into one of the biggest, baddest, most fundamental rules in the entire universe. We're going to start with Einstein, sure, but we're going to end up somewhere much, much weirder, in the quantum realm, where the truth behind this cosmic speed limit is way stranger than you probably think.
So here's the question we've all asked at some point, right? Why can't we just build a better engine, put the pedal to the metal, and break the speed of light? The usual answer you hear is something about needing infinite energy. But you know what? That's not the real reason. That's just a symptom. The real reason is way deeper. It's woven into the very logic of how reality works.
And this is the key. We have to flip our thinking. The universe isn't acting like a cosmic traffic cop just telling us to slow down. It's enforcing a rule of logic. It's a fundamental principle that stops reality itself from collapsing into a stream of nonsensical paradoxes.
Okay, so first things first. Let's get one thing straight. We call it the speed of light, but the limit has almost nothing to do with light itself. No, it's about something far more universal.
You know that famous little c and E equals mc squared? Well, that's not just the speed of a photon. It's the speed of causality. It's the top speed for any kind of influence. It's how fast a cause can create an effect. It is the transfer speed of information itself.
So just think for a second about what would happen if you could break that rule. I mean, really think about it. You could get a reply to an email before you even sent it. You'd see a window shatter, and then someone would throw the rock. The whole this happens, then that happens sequence of reality would just break. Cause and effect would be totally meaningless.
And I just love this way of putting it. The universe isn't just a collection of random rules. It has this deep, baked-in logical consistency. So when it's faced with a paradox, something that makes no logical sense, the laws of physics themselves just throw up a giant stop sign and say, nope, not happening.
So how does the universe actually enforce this? How does it stop things from creating a paradox? Well, this is where Albert Einstein enters the picture. He figured out that the fabric of reality has its own defense mechanism, a kind of cosmic paywall that gets infinitely expensive to climb.
See, Einstein's genius was realizing that space and time are not separate things. They're actually fused together, woven into a single four-dimensional fabric called spacetime. And everything in the universe, you, me, planets, galaxies, is constantly moving through this fabric.
Now this leads to a really wild consequence. Think of it like you have a total speed through spacetime that's always the same. So the faster you decide to move through the 3 dimensions of space, the slower you have to move through the 1 dimension of time. It's a cosmic trade-off you can't escape.
And here's that paywall in action. Because of E equals mc squared, as you pump more energy into something to make it go faster, some of that energy turns into mass. The object actually gets heavier, which means you need even more energy for the next little push. It's an insane feedback loop. As you get closer and closer to C, the energy cost just goes vertical. Until at C itself, the price is literally infinite. Nature makes you pay an infinite amount to break its rule.
Okay, so we've got the what and the how from Einstein. But to really understand the deep why, we have to go quantum. And for that, we need to talk about the brilliant and eccentric physicist Richard Feynman.
Now get ready for this because it's one of the weirdest ideas in all of science. Feynman figured out that to get from point A to point B, a particle like an electron doesn't just take a single straight path. Nope, it takes every single possible path, all at the same time. The straight ones, the loopy ones, the ones that bounce off of Mars for no reason, all of them.
And here's where it gets truly wild. In this model, every possible path includes paths where the particle travels faster than light. So, in the strange world of quantum mathematics, those impossible journeys are actually on the table. The universe considers them. But, and this is the absolute magic of it, when you do the math and add up the probabilities for all of these infinite paths, something amazing happens. All the weird, causality-breaking, faster-than-light paths perfectly cancel each other out. They literally erase themselves from reality, leaving only the paths that obey the universal speed limit.
So what this tells us is incredible. Quantum mechanics is perfectly happy with all sorts of weirdness. Particles being in 2 places at once, you name it. But it draws a hard line at paradoxes. The moment something would break the fundamental logic of cause and effect, reality's own math just vetoes.
Now, I know all this talk about space-time and causality can feel a little out there. So let's try and make it visual. Physicists have a really powerful way of picturing all this, and it's called a light cone.
So just imagine an event happening right now, like you snapping your fingers. The light from that snap spreads out in an expanding sphere. Now, if you map that expanding sphere across time, you get the shape of a cone. That cone represents the boundary of your influence on the universe, starting from this exact moment.
And this cone divides the entire universe into two parts, relative to you. Everything inside your future light cone is your possible future. It's every event you can ever influence, every person you can ever send a message to. But everything outside that cone, that's called the elsewhere. And it is forever, fundamentally, beyond your reach. To get there would mean breaking the speed of causality.
And this gets us to the ultimate point. This was never really about a speed limit on spaceships. It's a limit on information. It's a rule about which parts of the universe are allowed to communicate with which other parts. This isn't just a traffic law. It's the source code of reality itself.
So, does all this mean we're stuck? Is the dream of interstellar travel totally dead? Well, maybe not. Because whenever scientists find a rule that seems absolutely unbreakable, they don't just give up. They start looking for loopholes.
So, is it really impossible? I mean, is a breakthrough completely off the table? Well, if you try to tackle it head-on, probably. But the greatest breakthroughs in history often come from not breaking the rules, but from understanding them so deeply that you find a clever way around them.
So this leaves us with two different ways to think about it. The first approach is trying to smash the limit, just trying to power a ship through space-time faster than c. We've seen that's a dead end. But the second approach is to reinterpret the limit. What if, instead of moving through space, you could move space itself? What if you could bend and warp space-time to bring your destination to you? That is the absolutely mind-bending idea behind things like warp drives and wormholes.
And at the end of the day, that's the real lesson here. The speed of light isn't a wall we're supposed to smash through. It's a deep rule about the universe that we have to understand. Real progress, the kind that changes everything, comes from finding those clever loopholes in reality's code, not by breaking the laws of physics, but by using them in ways nobody ever imagined. And that leaves us with a final, tantalizing question. It's not just, how can we go faster? It's, what other fundamental rules of the universe have we been looking at all wrong?